Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 13, Section 2, Adding Polynomials. And really, this section is not super difficult, so it shouldn't take me long to get through this video. If you take a look at the polynomials being added here, it's pretty simple. You're basically just combining like terms. It's very similar to Chapter 3, Section 2. So the two polynomials we see here are 8q plus 3, that's our first polynomial, and 4q minus 2, that's the second polynomial. And they're being added. We put this little plus sign in parentheses to let you know that this bottom term is a second polynomial, and this plus sign means we're adding the top to the bottom. So essentially what we're going to do is we're going to add our like terms together. So we're going to add our q's with our q's, our constants with our constants, f's with f's, z's with z's. So it should be pretty easy for most of us to fly through this if we understood Chapter 3. So essentially what we're doing, we have positive 3 plus negative 2 over on the right side, which would get us positive 1. Over here we have 8q plus 4q, which would get us 12q. And since the 1 is positive, we have a plus sign between them. If the 1 was a negative, I could put plus negative 1, but since the 1 is positive, I'm just adding a positive 1. If we take a look at number 2, we have, once again, we've got two polynomials. We have 9f minus 3 plus negative f minus 15. So if we start with the f's, we have 9f plus negative f, which would get me 8f. And then negative 3 plus negative 18. Negative 3 plus negative 15 would get me negative 18. So one more time, negative 3 plus negative 15 would get me negative 18. So I would put plus, parentheses, negative 18. So I added my f's and I added my constants. Now you could have also written 8f minus 18, but typically we like, especially in my class, I don't like to see subtraction signs because you can always keep, flip, change, or add the opposite to turn it into an addition problem. Addition is just a lot more useful and flexible than subtraction. Subtraction is very limited because you can't flip the numbers around. So down here, you're going to notice the problems they look a little different, but in reality, they aren't any different. They're just set up horizontally instead of vertically. So basically, at this point, it's your job to take the problem and set it up. I suggest you take the problem and you set it up so that it is vertical like the ones above. So like take question 11 and set it up so it looks like questions 7, 8, 9, and 10. So what you're going to want to do is basically I would take your r squared, put it underneath your negative 4r squared. Take your 9 and put it underneath your 10. And so what you're going to notice is your 6r is going to still be part of your answer, but it's not going to change because there's nothing to add to 6r. Basically, you'll be doing r squared plus negative 4r squared, which will get you negative 3r squared. And I put the little caret here to let you know this 2 is actually an exponent. So this means negative 3r squared. Okay, so positive 1r squared plus negative 4r squared is negative 3r squared plus 6r, because there's nothing to add to the 6r, plus we have 9 plus 10, so 19. So we'd have negative 3r squared plus 6r plus 19. Again, I expect when you're showing your work that you set the problems up so that they look like this. That way when I go to check over your work, it's very easy for me to see whether or not you combine the correct terms together. If I see that you put your r squared underneath 6r and added those together, then I'll know very quickly that your mistake was simply that you just combined incorrect terms together. However, if you got the wrong answer, but you set everything up correctly, then I know that the problem lies elsewhere. And I can address that with you. It will help me correct your mistakes. So please make sure you're showing all your work. Please make sure you're setting your problems up vertically. Problems 11 through 22 require a little bit more effort on your part because you have to basically rewrite the problem so it looks like questions 1 through 10. But really that's all there is to this stuff. Just a quick refresher for those of us who forgot. If we take a look at question 21, for example, we have 3ab squared on the polynomial to the left of the plus sign, and on the polynomial to the right we actually have ab. Now you cannot add 1ab to 3ab squared because they're not like terms. So that's something that you got to remember. Even though they look like they are, they're not, because the 3ab squared has a b squared, and the 1ab doesn't have a b squared. Their variables aren't the same. This one is a times b times b. This one is just a times b. Really, in this problem on number 21, the only two things you can add together are the negative 1 and the positive 3, because the a squared cannot combine with the 2a. They're not like terms either. So for this problem, you would actually have 3ab squared plus ab, or no, 3ab squared minus 2a plus ab, we'll go plus a squared plus ab plus 2. So the 3ab squared just drops down, the minus 2a drops down, the a squared drops down, the ab drops down, and the only thing that changes is the minus 1 and the plus 3 are combined together to get you plus 2, because there were no other like terms in this problem. So any questions on that, please let me know. If you didn't take good notes or you didn't take notes at all, please make sure you remember, go back, watch the video, pause it when you need to, take some notes. You should always have examples of what you've done that will help you kind of figure out things, but you should also have some writing in your notes to explain what the examples are doing or what's happening in the examples. So between the writing and the example itself, you should hopefully be able to figure out what is going on. But that is all for this video. Next video will be on Chapter 13, Section 3.